let's talk about conformations, right? I am going to use the structure of ethane. I'm going to use ethane to explain what conformations are, right? Now, here I have 2D, your regular 2D structure of ethane, and your 3D, right? This is your ball and stick. Both of these structures are the same, right? Except I just have represented them differently. I gave you a 2D. Here we have a 3D, right? This is the ball and stick that you'll make when you buy models. You should buy models, right? Um, and then over here, this structure and this structure represent the same, right? I just drew them. They're shown differently. This is a ball and stick. That's your 2D. So 2D, 3D. All right, let's go. Now, if we take a look, and let me just show you why they're the same. Here's my carbon in the front. The front carbon is the carbon that is closest to you. This carbon corresponds to this carbon, right? This is your front carbon. Your front carbon has a hydrogen here, here, here. It's the same. The carbon in the back here has a hydrogen pointing up to the side, to the side, to the side, to the side. They're the same. All right, cool. Let's talk now. So we have ethane, and I'm going to compare these two structures. I'm going to call this A and I'm going to call this B. So let's talk about A and B. All right. The molecular formula for A and the molecular formula for B is the same, right? Same molecular formula. What about the connectivity? The connectivity is also the same. The carbon in the front has three hydrogens bonded to it, and that's CH3 in the back. Carbon in the front here has three hydrogens, and that's CH3 in the back. This and this have the same molecular formula, same connectivity. And if you look here too, it's the same molecular formula, same connectivity. I know you see the difference, right? If you look, the carbon in the back remains the same. There's no difference in terms of how the hydrogens are arranged, right? Cool. What about our front carbon? If you look at your front carbon, I have two green hydrogens pointing to the left and the right side, right? And one pointing down. This carbon over here, what's happening? Don't have the same arrangement, right? Guess what? A and B are different conformation of ethane, right? So the molecular formula is the same, the connectivity is the same, right? And remember, connectivity is what's on the carbon. So this carbon has three hydrogens, this carbon has three hydrogens, and a CH3 in the back, same thing. So same connectivity. The only thing that's different here is the arrangement of the hydrogens on this front carbon. This is one conformation of ethane, this is a second conformation, right? So and they're called conformational isomers. So what's our definition for conformational isomers, or what are conformers, or what is conformation? So this is what conformation is, right? It's different arrangement of atoms in a molecule that has the same molecular formula and the same connectivity, but this difference in arrangement only resulted because of the rotation about this carbon-carbon single bond, right? Now, you will see that a lot when it comes to conformations. It's about the rotation about the carbon-carbon single bond. Now, this is what we're going to interpret that as when they say that. What that means is that rotation at either the front carbon or the back carbon, both of them do not rotate at the same time. As you can see, the only carbon rotated here was the front one. Okay, so when when you have a molecule and you have rotation about a carbon-carbon single bond, right? It can result in a conformation. So that's how conformation is, right? It's a new molecule or a new shape of a molecule that results that occur as a result of rotation about your carbon-carbon single bond. And remember, I said that that rotation about your carbon-carbon single bond honestly just simply mean is either the front carbon is rotating, and when that front carbon rotates, these rotate with it, which is what this is showing. This hydrogen moved to here. This one dropped here, and then this one moved up here, right? So conformations are literally 3D arrangements, right, of atoms in a molecule that results because you rotated one of the carbons of a carbon-carbon single bond. Okay? So when you do that, you get different conformations. Same molecular formula, same connectivity, A and B, same molecular formula, same connectivity. The only difference was the arrangement of the hydrogens, right? And that tells me that these two things are conformers. If you want to look at it with your ball and stick, right? Here we have our two carbon, front carbon, back carbon. The back carbon is the carbon that's furthest away from you. This carbon is closest to you, so it's the front carbon. If we compare these two, the back carbon did not rotate. It was the front carbon, right? And as the front carbon rotates, notice what happens so that you now have a hydrogen here facing this one. So this is one conformation, which is the staggered. I'll do a video on that. And this is your eclipse conformation. Notice the molecule has the same molecular formula, same connectivity. The only difference is that on the front carbon, the arrangement of the hydrogens is different. The only reason they are different is because this carbon here rotated. So just remember, conformations. If you want to look at it this way, same molecular formula, same connectivity, right? The only difference is the arrangement of the atoms in space. Remember, those atoms arranging differently, these are the atoms that are arranged different. They're only arranged differently because of the rotation at this carbon-carbon single bond, which simply just means that this front carbon rotated. Bear in mind, always remember, if the front carbon is rotating, the back carbon stays in place. That's what that rotation about a carbon-carbon single bond means. The rotation is about this carbon-carbon single bond, which means either this carbon will rotate, that stays in place. If this rotates, then this one will stay in place. So conformation, so these two, A and B, are what we call conformational isomers. They fall under stereoisomers. Different conformations have different energy. We'll talk about that when we talk about staggered and eclipse.